Good day everyone, we are the 7th team with me Vincent and my friend Deon. Before we start, we would like to present our gratitude to Mr. Andreas and assistant that have guided us in order to finish this task. We also want to thank all of our friends that attend in this opportunity. There are a few subjects that we will discuss today. The first one is soil bearing testing, and then plate bearing, and the last one is California bearing ratio or CBR field. First one, soil bearing testing. What is soil bearing testing? A soil bearing test will determine if the type of foundation you are planning for your new home will be suitable for the property's soil conditions. For most new home builds, the city you are building in will require you to have a soil bearing test done as a condition of your building permit. The city will only accept a soil bearing test sealed by the licensed professional engineer registered in your province. While they are an important factor in ensuring your home will be structurally sound, your foundation is one of the most important parts of your new home. Having a soil bearing test done ensures that it will be designed to suit your property's conditions. Foundations that are not designed to meet the soil conditions can cause ongoing movement and cracking throughout the life of the home. Future problems resulting from the soil poor conditions in inadequate conditions are very challenging and expensive to fix. So even if you don't need a soil bearing test for your new building permit, it is a good idea to have it completed by a qualified engineer registered in your province. The soil bearing test will help you make sure you are taking every step to ensure your home will be structurally stable. A properly designed foundation could save you money and headaches from preventing future problems. Alright, the second one is plate bearing. Plate bearing test. Plate bearing test, also known as a plate load test or static load testing, is an in-situ load bearing test of soil. The activity of plate bearing test is performed in order to determine the bearing capacity of soil underneath that is likely to take the anticipated load or a temporary or a permanent structure. It is important to note that this test method assumes that soil strata down towards the depth and in relation to the influence of stresses are reasonably uniform. Alright, the next one is purpose of plate bearing test. There are three purposes of plate bearing test. The first one is confirmation of the assumed bearing capacity during its design stages. The second one is estimate the design parameters related to soil bearing capacity. And the third one is estimate the likely settlement of the foundation under the working rod. Alright, in order to do this plate bearing test, you also need kind of apparatus. Like the first one is counterweight. Counterweight can be any heavy material that is stable and rigid. The second one is hydraulic jack or load cell with pressure gauge. The load from the counterweight assembly is transferred to the bearing plates by means of hydraulic jack. The third one is probing ring. A probing ring may be fitted with the jack having 1 kg accuracy for measurement of the load. And the fourth is bearing plates. According to BS, the circular bearing plates are recommended. The largest dial plate will be placed on the ground and the other plates would be placed in a concentric manner. The fifth one is 4 dial gauges. These dial gauges will be used for checking the settlement of the bearing plate. These gauges must be checked for any zero error. And the last one is reference beams. These dial gauges are fixed on reference beams that are extended far from the loading zone where no impact of the settlement is expected. The next one is procedure of the test. The first one is preparing the test site. The plate load test is normally carried out at the design foundation level or the anticipated level of the footing, i.e. it can either be on the surface or a shallow pit up to the desired depth. It can be excavated for carrying out the plate bearing test. The second one is selection of the size of bearing plate. Keeping in view the anticipated design load of the structure, the size of the bearing plate is decided by the engineer at site. A size between 300 to 600 mm is very reasonable. The third one is excavation and preparation of the test pit. Excavate to the test level as quickly as possible to minimize the effects of stress relief, particularly is cohesive fields. A mechanical excavator may be used provided that the excavator bucket does not have teeth and the last 100 mm depth and excavation is carried out carefully by hand. Carefully trim off and remove all loose material and embedded fragments so that the area of the plate is generally level undisturbed as possible. And the fourth step is setting up the loading device and deflection of recording devices. Set up the loading and deflection measurement systems so that the load is applied to the plate without asymmetry and the deflection system is outside the zone of influence of the attachments. The fifth or the last step is application of load and not deflection readings. The load shall be applied in 5 increments. Settlement reading will be taken at 0.50 minutes intervals for the first 2 minutes and 1 minute intervals thereafter until detectable movement of the plate has stopped, i.e. until the average settlement rate is less than 0.02 mm per 5-minute interval. And next is plate bearing advantages. The first one is gain understanding of foundation behavior, which will enable the evaluation of foundation bearing capacity and settlement under rolling condition. The second one is quick and easy to perform. And then the limitations. Plate bearing test can give bearing capacity of subsoil up to the depth about twice of plate diameter only. And then there is a scale effect due to size of testing plate is smaller than the actual footing. And the third or the last one is the settlement influence zone is much larger for the real foundation sizes than that for the test plate, which may lead to gross misinterpretation of expected settlement for proposed foundation. In order to understand better about this plate bearing test, let's watch the following video clip.
So the first thing you need is a reaction load, and in this example we're using a very large dumper, sometimes called a moxie, and the intent is to use the rear axle here as a reaction load to push the plate into the ground. So the first thing we need to do is to prepare the ground. We've got a nice flat surface, but we need to use some bedding sand put underneath the plate so the entire surface area of the plate is in contact with the ground. So we don't fill any holes in with natural material, and we have a bed of sand which is very, very thin, just filling those voids. So now we have a nice flat area ready to receive the plate. So down the plate goes with a circular motion, toing and froing, again to make sure that the entire plate is in contact with the surface of the soil. Now this is a 600mm plate we're using here. You can use different sizes. This one will give a zone of influence under the plate of about 1.2 meters, which is what the client requires for these tests. So next we add a stiffening plate in the centre of the bearing plate. And then we have our load cell on next, again placed in the centre of the stiffening plate. Now that will measure up to 100 kilonewtons, 10 tonnes, with an accuracy of 0.1 of a kilonewton. Then we add a couple of spacers. And now the jack. Pop the jack under there. The spacers are too high, so I need to swap them. Or some smaller ones. So we pop that one there, and on top, let's see how we're looking. And that's hanging plumb. So as you can see, we now have the hydraulic pump and jack load cell assembly in place, and the readout unit somewhere around there. So now we need to put the datum bar in place with the dial gauges on, which will measure the settlement of the plate. So this is my 2 metre long datum bar with the dial gauges already attached. And I'll put that roughly into position, and then I'll move the dial gauges to get them all nesting neatly on top of the plate. So we have the 3 dial gauges in position, spread across the plate like that, and the test is just about ready to start now. We just wait for everything to settle down and we can begin the first loading increment. Right, so this is one of the gauges, one of 3, and they're all zeroed and we're ready to start the test. So we're at our first load of 5 kilonewtons, which will now leave until the settlement virtually ceases, and then we'll increase it to 10 as per our client's specification on this job. So we've applied the second load increment, we're at 10 kilonewtons now, and we're just monitoring the settlement and then writing it down here. So to move up to the next increment, we just use this hydraulic ram, jack I should say, until we get the required level on that loadout. And you can see there how the jack has risen as it's lifting the reaction load up and pushing the plate into the ground. All seems well on the final increment. 5 we've done. Oh, and I forgot to mention, of course, we are timing the test, each increment, and we note down the time that it starts and finishes. And after all the increments, there's no unloading requirement on this test, so that's the end of the test. All we need to do now is just release the load and disassemble the equipment. So let's let the load off. Piston begins to fall. Hopefully it'll start to drop out, and there it comes. And that's it. And now, just to relax and enjoy the wonderful Derbyshire countryside.
That's all for the plate bearing test, and the next one will be explained by Dan.
California Bearing Ratio (CBR). The California Bearing Ratio or CBR test is performed in construction materials laboratories to evaluate the strength of soil subgrades and base course materials. Those who design and engineer highways, airport runways and taxiways, parking lots and other pavement rely on CBR test values when selecting pavement and base thicknesses. In the early 1900s, economic development drove the demand for more miles of better quality roads, which in turn resulted in increased road traffic. In 1928 and 1929, engineers at the California Division of Highways, now Caltrans, developed the CBR test to ensure pavement could be economically constructed and still carry the anticipated axle loads. They established the penetration resistance of ideal crushed rock-based material as a standard reference to compare against all other soil and base course materials. California officially adopted the CBR test in 1935, and it is now a standard method in ASTM, AASHTO, US Army Corps of Engineers, British Standards and others. CBR test purposes. The main purpose of the California Bearing Ratio test is the measurement of a soil resistance penetration before reaching its highest ultimate value of a shearing. The second one is basically to California Bearing Ratio value is defined as a ratio in percentage of range 0 to 100. The third one is the important operation of conducting the California Bearing Ratio test are same of variations of various soil condition and various type of construction. The fourth one is California Bearing Ratio test is used for the evaluation of subgrade strength of road and pavement. The fifth one is California Bearing Ratio value used as an index of soil strength and its bearing capacity. The sixth one is the result obtained from the CBR test are used with the imperial curves for determination of the thickness and pavement and various component layers of pavement. CBR test methods. The laboratory test method in ASTM D1883 and AASHTO T193 for the CBR test is a simple empirical method, comparing resistance to penetration of the test specimen to that of a standard sample of well-graded crushed stone material using a standard size piston. The test doesn't characterize any soil properties aside from resistance to penetration. The second one, CBR testing also performed in place on soil substrates with an apparatus using the same size penetration piston or with the dynamic cone penetrometer. STMD4429 is often used as an exploratory test to determine in-place condition of soils or bases or to confirm laboratory test results. CBR field test apparatus, field CBR loading jacks, connector set for CBR test, field surcharge plates and messes, piston extension set for field CBR test, 2,000 and 5,000 pound load ring, mechanical dial indicator, penetration piston for CBR test, dial support bridge for CBR test. CBR test procedure. Determine the test point where the distance of the test point is determined and do not interfere with the test at the next point. The minimum distance between penetration test points on plastic soils is 175 mm or 7 inches, while in glandular soil the minimum spacing is 380 mm or 15 inches. Prepare a surface area at the test point according to the depth of the layer to be tested by removing loose material and making the area flat so that the test can be carried out. Place the truck in the center of the test point location. Install a jack to raise the truck so that it no longer rests on the springs. Place the jack in the correct position on the test site. Then connect the test ring to the end of the jack. Connect the auxiliary pipe to the penetration piston and secure the jack in place. Check and fix the assembled jack so that it is in a vertical position. Place a load plate weighing 4.54 kg below the penetration piston so that the penetration piston can enter the hole in the load plate. Adjust the penetration piston so that it can provide a load about 3 psi. For a quick adjustment, use the high gear rotation of the jack. The surface area of the test area must be flat so that the load acting on the load plate can be distributed evenly. Give an additional load on the load plate so that it is equal to the load acting on the pavement, except for the minimum loading of 4.54 kg on the load plate, and plus 1 additional load of 9.08 kg. Install the penetration gauge on the piston. Set the measuring watch to show 0. Apply a load to the penetration piston at a constant penetration rate of approximately 1.5 mm per minute. Use low gear rotation on the jack during the test. Record the load reading at the initial penetration of 0.64 mm to the end of 12.7 mm in depth. Then calculate the ratio of stresses expressed in percentage. After completing the field CBR testing, conduct a field water content test with a speedy device according to SNE 03196512,000 and a field density test with a sand cone according to SNE 0328271992. The test is carried out at a distance of 100 mm or 4 inches to 150 mm 6 inches from the point of penetration. California bearing ratio. Advantages. The test can be performed by personnel with relatively little experience and training. The CBR method adapts more quickly to airfield pavement design for immediate use than any other method. You can test soil with simple portable equipment. Testing can be done in sample representative of future water conditions. Disadvantage. The laboratory and field compaction methods are not identical. However, comparative tests indicates that reasonable correlation of results can be obtained from field compact materials and samples compacted under similar conditions in the laboratory. Because added strength to highly stabilized surfaces such as asphalted concrete is neglected, the assumption of a completely saturated substrate condition sometimes results in a too conservative sector of safety. Because many of the procedures are of an arbitrary nature, you must run the test to exact standards in order to design tables to be valid. For further understanding of CBR field testing, let's take a look of this short clip.
Roses are red, violets are blue. That's all from us, and thank you.